here where the magnetic fields would have the possibility to interact if these wires were close together. So here, this arrow is going that way, and this arrow is going that way. Like at that point on that magnetic field, that's where those arrows are going. I just drew them again just to kind of visualize more clearly. So if the magnetic fields are going in the exact same direction, will the magnets be repulsed or attracted? Why do you say that? Because they're the same, similar repel. Okay, yes, you are right. So if I had wires like this, this would be repulsion. Because same magnetic fields. Again, we'll try and kind of do some activities where you get to do this yourself and see it. So we can see that. So they go in different directions. So now let's do a second example where we put two wires that are the same. So let's say they're both coming out. So now, if we look, here's this arrow is going that way, and this arrow is going that way, at those points where those magnetic fields can match up. So, based off of your reason for this one, what will this one be like? Attraction, yeah. So here we will see attraction. Because opposite. Magnetic fields at that point. And I should say at that point for this one too. Because it's not that the magnetic fields are, like they obviously have they have the same rotation of magnetic field, but at that point the arrows are different. Is that clear? Okay. So now we can take these principles and make something called a solenoid or an electromagnet. So now this is really important, okay? When a conductor wire is wrapped into many loops, okay, so it's like you take that wire and you wrap it around and around and around, you get a solenoid or an electromagnet. So, and these are applicable a lot in motors, okay, and things like bells and stuff. So here is like what a solenoid would look like. A solenoid though will have a hollow center. An electromagnet has a solid center. Okay, so that's the difference between the two. So I'll try and get this working too, and you can play with it. So it's now called a solenoid or an electromagnet. So a solenoid has a hollow center, an electromagnet has solid center. Okay? So it'll look something like this when we represent it in diagrams, and we need to be able to connect it to like a battery or plug it in or a motor or something, because we need that electric current to flow through. Okay, so when we hook it up, we have to say what its battery is like. So here on our diagram, let's just look at what's going on here. So depending on if it's solid or hollow, this object is a solenoid or electromagnet. Now, if the battery end, let's think about this, if this end is negative, what can I conclude about how the electrons are flowing, do you think? In a battery, what? It comes out of the negative, actually. So it's like, think about that negative as being like the source of negative, and it's flowing out. And then it's kind of being attracted back to the positive.
So
if that could.
Wrap around?
Where does it wrap around?
What?
Oh, like either if it's like a hollow center, it would just be like a tube of metal. And if it's solid, it would be like just a solid cylinder of metal. Yeah. So when we think about this, we have our electrons, they come and they're flowing out of the negative. So now if I think about it, it comes up, it wraps around. So now at this point, when I look at it, my electrons are flowing that way. Okay, so it's like if it's coming, wraps around, and the electrons are flowing up. So it's going like this. At all those open-faced wires. And I can actually give you some, if you want to, some wire, just to even, while you're sitting and kind of visualizing, if you want to. I don't know, it kind of helps me sometimes if I just, take a piece of wire and wrap it. We're not doing anything specific with it, but it kind of can help just to be like, okay, if the electrons are coming out here and it goes this way, so if you want a piece of wire, you can kind of use that as we're going through. I'll get some more.